We continue our discussion about the derivative with the following problems. You're going to be asked, of course, to find the slope of the tangent line. Remember, that means the derivative. And right now we're going to be using that definition of the derivative and maybe that four-step process. We're going to find the slope of the tangent line to the graph of the function at a given point and determine an equation of the tangent line. So previously we found just the derivative in general. Now we're going to find the derivative at a given point. So let's go ahead and just start that process. What is that definition of the derivative? Remember, it's the limit as h approaches 0 of f of x plus h minus f of x over h. So I'm going to first find f of x plus h. This is a great time for you to pause the video, you find this math, and then come back and check your work. On this step, you want to make sure that you FOIL this out first and then distribute your minus sign. Now remember, we then need to subtract f of x. So just like in the previous video, I'm going to snag this, bring it down here, and I'm now going to subtract my given function. I'm going to collect like terms, so let's see. Those add to 0, those add to 0. So I'm now left with 3h minus 2xh minus h squared. So the next step is I'm going to divide by h. So if I factor the h out, I have. So the last step is I'm going to find the limit as h approaches 0 of 3 minus 2x minus h. So as h approaches 0, my derivative is 3 minus 2x. So that's the slope of the tangent line. That's my derivative. Now how do I find that derivative at the given point? Well, my given point is -2, -10. So the next thing I need to do is I need to let x equal to -2. So again, I'm coming back up to here. 3 minus 2 times -2, which is 3 plus 4, which is 7. So the slope at the certain point is 7. The next thing it asks me to do is find the equation of the tangent line at that point. So we've got to go back to college algebra and review that. And we've seen that formula before. So I have the point -2, -10, and I have a slope of 7. So I just want to use that. Y minus a minus 10 is plus, and same thing here. I'm going to subtract the 10, and I would get y equals 7x plus 4. So that is finding the equation of the tangent line at a certain point. You're going to be asked to do that in chapters 3 and 4. So keep in mind, we find the derivative, we find the slope, we find that equation. Let's just practice this one. It's a little bit different in the algebra because we have a fraction. We have that x in the denominator. So I'm going to take that definition of the derivative, and I'm going to kind of combine a couple of steps here. So I'm going to do f of x plus h minus f of x. So we have -1 over 2 times x plus h minus this. So I have -1 over 2 times x plus h plus 1 over 2x. Again, negative and a negative. So how do we add those fractions? We have to find a common denominator. So they both have a 2, so we're good here. But they both need to have an x and an x plus h. So I need to multiply this fraction times x and this fraction times x plus h. And so my common denominator is 2, the x, and the x plus h. So I multiply that together and I get -1x. Multiply this together and I get x plus h. and of course that adds out to 0. So what's the last part, or the next part of finding the derivative, is I have to take this and of course divide by h. So I have h over 2x times x plus h, but I have to divide by h. I'm writing it a little bit differently so you can see it. I know a lot of people don't like fractions. So how do we divide? This is in the denominator. We're dividing by h is the same as multiplying by 1 over h. Since I have an h in the numerator and h in the denominator, those divide out, and I'm left with 1 over 2x times x plus h. Remember, that last step is to take that limit as h approaches 0. So this goes to 0, and I'm just left with 1 over 2x times x, 1 over 2x squared. So that is my derivative, or the slope of the tangent line in general. Now I have to find the slope at a certain point. So now we're going to let x is equal to 3. So 1 over 2 times 3 squared is 1 over 18. So that's the slope at that point. So now I need an equation of a line. So I have the point 3, negative 1/6, and I have a slope of 1/18. So I have y minus a minus 1/6 equals my slope times x minus 3. Now a lot of you are going, ugh, don't like those fractions, but look at what happens. We have y plus 1/6. If I distribute, that's 1/18 times x. Now remember, this is 1/18 times negative 3 over 1. That's negative 1. How many times does 3 go into 18? 6 times. So that's what's kind of nice. So now when I subtract this 1/6 to that side, I have the same denominator. So I have y equals 1/18 x minus 2/6. Negative 1/6 minus 1/6. Then of course you would reduce. And so that's the equation of the tangent line at this given point. So the next thing you're going to be asked to do, of course, is to find the derivative and look at how they have changed that notation. Right? So that's that little f with a little prime mark. That is finding the derivative. Again, we would go through that same process. So since we've already found the derivative of this function in a previous example, and we got this, what are you going to be asked to do now? We're going to be asked to find the point on the graph where the tangent line is horizontal. What does that mean? Well, remember, the derivative is the same as the slope of the tangent line. So if I want the tangent line to be horizontal, that slope is 0. In other words, I want that derivative equal to 0. That's what it's saying, and again, that's going to come up pretty much through the rest of the semester. But it's really easy. So once you find that derivative, you set it equal to 0 and solve for x. Now, it asks you to find the point. So that's the x value. You also have to find the y value. How do you do that? Well, you go back to the original function, because f of x, y equals f of x of 3x minus x squared. So I want to know when x is 3/2, what is y? So I have y equals 9/2 minus 9/4. So finding a common denominator, that's going to be, let's see, if I multiply this times 2 and that by 2, I'd have 18/4 minus 9/4, which is 9/4. Sorry, I didn't leave myself really a lot of room. So the answer would be when x is 3/2, y is 9/4, and that's the point on the graph where the tangent line is horizontal. One of the last things we're going to look at is how does that derivative, which is the instantaneous rate of change, compare to that average rate of change. Go back where we talked about the secant line approaching that tangent line. Average rate of change versus the instantaneous rate of change. That's what we're going to calculate and make a prediction. So how do we find that average rate of change? That's just the slope. That's f of x2 minus f of x1 over x2 minus x1. Really, it's the change in y over the change in x. So we're given our two values, and look at how this one stays the same. So if you remember way back, we talked about how we had secant lines and we were getting closer and closer. And this is what this is going back to. So I have to evaluate the function at 3. So I'm going to say 3 squared plus 3, that's 12. And I need to evaluate the function at 2. So that's 2 squared plus 2. What is that? 4 plus 2 is 6. Right? So my average rate of change, or my slope, I'm going to say this is 12 minus 6. Okay, so remember, look at here. I did the 3 and this first, so that means I need to do the 3 first on the bottom. So I have 6 over 1. So the average rate of change between 3 and 2 is a slope of 6. Well, the next thing they ask us is to say, hey, instead of between 3 and 2, what if I go from 2 to 2.5? So I need to evaluate the function at 2.5. And this is where a calculator would definitely come in handy. So I used my calculator and I got 8.75. Since I already know f of 2, I don't need to recalculate that. So my slope is 8.75 minus 6. So again, I'm just replacing this with 8.75. And on the bottom, I'm replacing the 3 with the 2.5. So this is what 2.75 divided by 0.5. And again, using my calculator, I get 5.5. So that slope has gone from 6 to 5.5, so it's changed just a little bit. So now we're going to say, well, let's make it even closer. Let's go to 2.1. So my function evaluated at 2.1. Again, using my calculator, I get 6.51. So 6.51 minus the 6 over 2.1 minus 2. And again, replacing those values. So I have 0.51 divided by 0.1, I have 5.1. Okay, so now, let's see. We've gone from 6 to 5.5 to 5.1. So what would be your prediction instead of 2.1, 2.01? Or 2.001, letting it get closer and closer. In other words, what do you think that limit is? Well, my prediction is that the slope, or the instantaneous rate, or really that derivative, is going to be 5. Well, let's see. So if I want to find the instantaneous rate, that means to find the derivative. Okay, so how do we do that? With that process. I'm going to let you do the derivative, come back and check it. I'm not going to show my work. I'm just going to write down what that derivative is. So hopefully you have worked it out. You've done the limit. We've got the derivative. And now we want to know, what is that derivative evaluated at 2? And sure enough, I get 5. So that matches my prediction, and hopefully you're understanding how that average rate of change goes to instantaneous by taking the limit as it gets closer and closer, as that denominator gets closer and closer to 0.